Fast lookups win games. Your code is about to get smarter. Maps and sets change everything. In this chapter, we step into associative containers in C++. You'll learn how maps lets you connect keys to values for instant access and how set guarantees uniqueness and orders without extra work from you. These containers are not about storing data. They are about designing systems that scale, perform, and stay clean. Exactly the kind of thinking you need when building real game systems in Unreal Engine and beyond. This is the Game Creator Accelerator channel, and I am Tony Munoz. Like the video, subscribe to the channel, share it with someone learning C++, leave a comment, and ring the bell so you don't miss the next chapter. These small actions help me spread the word with YouTube's algorithm, and I truly appreciate it. If you're learning C++ because you want to build a career in video games and you want a repeatable path into the game development after office hours, visit woolen.com to learn more about the Game Creator Accelerator Lifetime Mentorship. You will see how this approach helps you build a scalable career in video games one step at a time. Then set a time to chat with me. The link is in the description. Now let's get started. In this lesson, we're moving into a different type of container called an associative container. And the first one we're going to learn is the map. A map stores key value pairs. That means every entry has a key, which is how you look it up, and a value, which is the data you want to store. You can think of a map like a real dictionary. The word is the key, and the definition is the value. In maps, the keys are unique. You cannot have two entries with the same key, and the map automatically keeps the key sorted, usually in alphabetical or numerical order depending on the type. Because the keys are sorted internally, searching for a key is extremely fast. Now, let's look at some examples. Because we're using maps, I need to include the library of map. For this example, let's create a map where the key is a string and the value is an integer. Here we have the definition of the map. The only thing I'm going to change is the name of this map. I will call it player scores. For the creation of the map, we identify it as a map in the standard library, and the first element is the key, and we have to establish the type, in our case a string, and the second element after the comma is the value, in our case an integer. With this, we initialize the map. Now let's insert some values. Let's start with player scores, let's say Alice, 150. The syntax is pretty straightforward. First, the name of the map, brackets, and inside the value of the key. Because it's a string, I will use this format, and then equals to the value that we will assign. Let's go with another. For example, Bob, and I want to add two more, David. Now that we have the values, how can we access them? To access the process is also pretty straightforward. We use the same syntax that we use when setting the value for a key. As you can see, the structure of this one and this one is exactly the same. It is the name of the map, and in brackets, we introduce the key. Let's recover the others. Bob, Charlie's score, and David's score. If we run this, we have the hello world at the beginning, and then the scores corresponding to all the players. Alice, Bob, Charlie, and David. Another fantastic feature of the maps is that you can update the value at any moment. Let's say that I want to update the value of David. I only have to say player scores. Let's change this for David. And let's add plus 50. Remove this one and say this is David's. Originally, David has 300. Now we have 50. Let's watch the value of the updated score for David and play it. At the beginning, David has 300, and once it was updated is 350. This is particularly useful when we're talking about features like keeping the score of your players in your video game. You can define a map with the name of the different players and you can control them individually. And the access to the values is extremely fast. The next feature of the map that I want to introduce is insert without overwriting. When you use insert, the map will only add the key value pair if the key does not already exist. If the key already exists, nothing happens. The existing value is kept. Let's go with an example. Let's try to insert player scores, insert, and let's say that we are inserting a new value which is Eve. If we try to recover the value of Eve, we will have it. It will be just a new pair that we are inserting into the map. And here is Eve. But let's now say that I want to add another value for something that already exists. Insert, let's say for Alice, that we already set here. And after that, let's see the value of Alice and see if we change the score. Remember that the original value of Alice was 150, and now we're trying to insert 220. If we play this, we can see that the original value of Alice is 150, and even though I tried to insert a new value, we kept the 150. We didn't update to the 220 because we use the insert method inside maps. This is a great feature that you might need at some point, so keep it in your notebook. In other occasions, you might want to do something in a map, but to avoid errors, you need to confirm first if that key value exists. To confirm the existence of a value, we use something like, let's say, if player score find Bob, which is our key, and it is different of player scores end, then we can assume that Bob is found in the map with the score, let's say player scores of Bob. But if it is not found, or if find Bob is equal to players scored end, then we assume that Bob is not found in the map. Again, let's test it. Bob is in the map, we know that, and this is why we get the message Bob is found in the map with the score 200. The syntax is pretty simple. It's just using the map, the method find, the key, and compare that with the map.end. If it's equal to the map.end, then this key is not found in the map. Now let's get to the usual methods to get information about the map. One is to get the size of the map. So players score.size will give you the number of key value pairs in the map. So let's use it as a standard cout size of the map, player size, to present how big is this map. Another important method is to check if the map is empty, which is a way for us to confirm if we can do something with the map. Before acting inside the values of the map, if we confirm that the map is empty, we can move to the next step of our code. To check if the map is empty, we ask literally, is the map empty? And the command to check it is the name of the map.empty. In this sentence, I added a question mark so I can compare the player's score, which is a boolean, is going to give me a value of true or false. And if it is false, because I'm using the question mark, I will use this value, which is yes. If this is false, I will use the other value after the colon, which is no. Let's test it. The size of the map is 5. Is the map empty? No. Excellent. Before we continue, let me share something important with you. This channel is part of a bigger journey called the Game Creator Accelerator Lifetime Mentorship. It's built for people who already have a life in motion, a day job, responsibilities, a steady routine, but still feel that pull to build something meaningful in game development after office hours. The goal is simple: real, measurable transformation into a game creator. Not just watching tutorials, not just collecting notes or certifications, but building proof by learning and creating projects using strategies that work and doing it inside a community that keeps you moving for the long run. Inside the GCA, you and I work together to build your first playable prototype in Unreal, learn the core principles you'll reuse on every project, and set up a path to share your work so studios, publishers, recruiters, and players can actually discover what you create. Then we lock in routines and a repeatable plan that keeps you consistent even when your schedule is tight or even when you are exhausted after work. This is the same approach successful indie creators use, myself included, and I learned it the hard way through frustration, mistakes, and even massive layoffs in the industry. Because today, learning in isolation and only sending applications isn't enough. You grow by creating, sharing, and building opportunities that comes to you instead of chasing them. And inside the GCA, we follow a clear methodology to make that happen, with my direct support, one-on-one sessions, and a selective community and lifetime access. If you want to learn more, check the link in the description. Visit william.com and book a call with me. The next command I'm going to present for a second and then I'm going to comment is how to clear the map. To clear the map, we use the name of the map and then the command clear. This removes all the elements from the map. In fact, let's check the size of the map after the clear. Here it is, and the size of the map after the clear is 0. Now we cannot obtain any value inside the map. Let's comment this out so we can continue. For the next section, let's say that you don't know the map that you have in front of you, and you want at the same time to iterate through all the key values on this map. So how do we iterate? To iterate in a map, we use the for, and in this for we have a const auto that we assign the value of pair, and pair represents all the keys and values inside player's score. It's not the key or the value, it's every element inside player scores. That structure that includes a string and an integer is the same structure for the pair. And that's why we use the word auto. I want to be automatically assigned the type of this value to be the value inside player scores. The best way to understand this is the next line. If we want to take the key of a value in player scores, we use the pair dot first. That will give us the key. And if we want to get the value, we'll use the same pair, but now dot second. This will give us the value. Let's understand it deeply by running the program. Here you have it. We are presenting, after the is the map empty, which was the last question here, the pairs of the key and the value of all keys and values inside the map. This is the way to iterate using maps. And finally, for maps, there is another method important to keep in mind, which is the count. The count is a value of true or false, 0 or 1. It will tell me if a key exists. It is different to find in the ways that finds look for a specific key. In this case, it's telling me if that key exists or not. But it is a more direct way to ask for this information. The way to call it is pretty simple. Let's say if player scores dot count, let's say Tony. If Tony is found in the map with score, then we'll present the player score. If Tony is not found in the map, then we present just this message. Let's check it. Here we have Tony is not found in the map. Perfect. Now let's talk about another associative container which is the set. A set is very similar to a map, but it only stores values, not key value pairs. You can think of it as a special collection with two very important rules. The first one, no duplicates allowed. The second, the elements are always sorted automatically. That means a set organizes itself behind the scenes. You don't need to sort it. You don't need to check for duplicates. It takes care of all of that for you. Let's create a very simple example. std set into year. Let's call this user IDs. Because we're using set, and I forget to add that one, we need to include the library. Let's go back to the bottom, and now we don't have the error. The next step for this example is to add a couple of values for this set. Let's say user IDs insert, users insert 2, and now let's repeat 1-on-1. If you try to do this in your set, it won't be allowed. It will only insert 1-on-1 and 2-on-2. But if you try to insert the next one, it won't happen. And the second cool feature is that they will sort it out automatically. So the 1-on-1 will be first and the 2-on-2 will be second. Let's count how many values I have inside this user's ID set. If you want to know the size of this set, use the command .size. At this point, we should have 2 because 1-on-1 is duplicate. Let's test it. We have our hello world and then the size of the set is 2. Perfect. The other command I recommend you to know is if the set is empty. Again, under the premise that you want to check if something is empty or not before taking action inside that set. Test again, and here we have, is the set empty? No. Excellent. Why we get the empty? Well, we use the command empty, and because this is a Boolean, we can give an answer in case it is positive or is true, or in case that it is false. The next method is about checking if a value exists. To check if a value exists, we use the name of the set and the command find and the key for that set. And then we compare it with the name of the set .end. If they are different, then we have that key inside that set. And if they are equal, then we don't have that key inside our set. Let me add another value to remove it later, which is the next command. Now I want to remove an element. Removing an element is straightforward. You use the name of the set .erase and the key that you wish to remove. Let's say I want to remove the 303. I know that before removing the 303, the size of the array was 3. In fact, I'm going to add a new line to compare before erasing the value. So let's call here before the size of the set before erasing 303. Now let's test it. The size of the set before erasing 303 is 3, and now after is 2. Perfect. The next command is about clearing the set. And to clear the set, the command is pretty simple. We use the name of the set and then clear. We can check the size of the set after clearing, just to confirm that it is working, and the size of the set is 0. Awesome. Now I want to iterate through the array, but to do it, before I'm going to add a value that won't be in order. So we have the 1-on-1, 400, 202, and then the 303. For the iteration, we use a syntax pretty similar, because I might not know what is the type of the keys in the user's ID. I can use auto, so I can immediately assign that type to ID. And then I can iterate, and it will only present the value of ID. That's the only thing I can do in sets. Let's play it. And here we have our set. And notice that it is in order: 101, then 202, and then 400. Why? Because sets does that automatically. A limitation because of the type of this container is that you cannot use indexing. For example, you cannot say user's ID is 0 and trying to recover the first element of this set. This is not allowed. But two important commands that you should know that are allowed in sets are how to get first and last elements. std cout smallest user's ID. The first element, as you can imagine, is the smallest user's ID because it is ordered, it is sorted. And to obtain that value, we use the dereference user's ID begin. And logically, if we want to obtain the last one, that will be the largest value. And for that, the command will be rbegin. Let's test it. Here we have it. The smallest user's ID is 101. That is correct. And the largest user's ID is 400. Awesome. Final important and cool thing you can do is to insert multiple values in one sentence. For example, you can say user IDs, insert curly braces, and let's say 600, 700, 750, and 245. And after inserting multiple elements, let's iterate. Now we have the original elements and with all the elements that we later inserted. And look that they are sorted. Awesome. You've now seen how associative containers like map and set help you design cleaner, faster, and more scalable systems in C++. These are the kinds of tools that quietly power real game mechanics behind the scenes. To help me continue building this channel and spread the word with the YouTube algorithm, like the video, subscribe to the channel, share it with someone learning C++, leave a comment, and ring the bell so you don't miss the next chapter. You'll find the full series and all chapters linked in the description, so you can follow along step by step. And remember to visit woolen.com to learn more about the Game Creator Accelerator Lifetime Mentorship. See how our methodology is changing the lives of people building a path into the game development industry, all after office hours, and then set a time to chat with me. The link is in the description. And until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.